Hello everyone, my name is Prince Pomri, and today we'll be talking about cache memory. When we say cache memory stores copies of data from RAM that is waiting to be used by CPU. Basically, the whole idea behind cache is to make the computer run faster and cheaper. Now, a computer can run without CPU cache, but it will be a lot slower. Memory. We have SRAM or the static RAM and dynamic RAM or DRAM. The DRAM uses capacitors to store data, and these capacitors have to be refreshed constantly in order for the data to be stored. It is faster than the DRAM and it boosts CPU's performance. Cache levels or cache hierarchy or the organization. Cache or the primary cache. This runs at the same speed as the processor and is the fastest cache in the computer. It is located on the processor. The level 2 cache is used to catch recent data accesses from the processor that were not caught by the level 1 cache. In earlier computers, level 2 cache was located on a separate motherboard, but in modern computers, it is also located on the CPU. The level 2 cache is larger than the level 1 cache, but not as fast as the level 1 cache. The level 3 cache is also used to catch recent data accesses from the processor that were not caught by the level 2 cache. It is also referred to as the shared cache because its memory is shared across all cores of the CPU. The level 3 cache is also larger than the level 2 cache, but not as fast as the level 2 cache. The level 1 and the level 2 cache have their own dedicated CPU cores. In a nutshell, if the CPU can't find the data it needs in the level 1 cache, it then searches the level 2 cache for the data it needs. And if the CPU can't find the data in the level 2 cache, it searches the level 3 cache for the data. And if the data it needs is also not found in the level 3 cache, the CPU then goes back to the slower RAM to find the data it needs.
Okay, everyone, I'm Sapon Israel Ejekumiao, and I'll be taking it from here. We are talking about the cache memory, and the next subtopic is the cache read operation. So, this is going to let us know of how the CPU gets data for its processes. So, when the CPU requests data, the address is divided into three parts, which is the index, the tag, and the offset. So as we all know, the CPU needs data. Whenever it needs data, it first checks the cache. It's the memory address that is divided into these three different parts. The first one being the index specifies the cache set. The index actually tells the cache where to look, as in like pointing to a shelf or a row inside the cache. The tag is used to identify if the required data is stored. This helps the cache to know if the data it found at the index is the correct one. If the tag matches, it's a cache hit. If not, it's a miss. So we have the cache hit and the cache miss. Offset, the last one, points to the specific byte in the block. Once the correct block is found, the offset tells the CPU exactly where the data is inside that block. Think of the block as a small group of data, and the offset helps the CPU to pick the exact piece it needs. If the cache has the right block and the offset, the CPU quickly uses that data it needs. If not, it gets the data from the main memory and updates the cache, which makes processing very slow. We move on to our next slide, and the cache controller searches for a tag match in the set. As I said earlier in the previous slide, if it finds this one to match with the index, it's called a cache hit. And this one, it returns the data immediately for faster processing. If not, it's the miss. which fetches the block from the main memory, causing a delay in processing. Move on to our next subtopic, which is the cache performance. And the performance is measured primarily by hit rate and miss rate. So the cache performance actually tells us how the cache is helping the CPU work faster. It is measured by how many times the CPU finds data in the cache, and this rate is called the rate at which it does this is called the hit rate. So the performance is measured with the primarily is measured with the hit rate, and when it misses is where we come with the miss rate. So a higher hit rate means better performance, and it's mathematically proven as number of cache hits over the total memory access. When there are many misses, the CPU takes longer to get data from the main memory, which slows things down. So the extra time taken to fetch data from the main memory is what we call the miss penalty. Our next slide. Optimizing cache performance involves increasing the hit rate, and the reducing the miss penalty. Techniques like prefetching and better replacement policies are used to improve performance. So the good performance means fast hit rate, fewer misses, and quick access to data. Thank you. This is where I end. My co-partner will take it from here.
I am Kingsley Nana Mensah, a member of Group 11. I'm presenting on least recently used cache memory. What then is a least recently used? In simple terms, it is a cache replacement policy that removes data that has not been used in the longest time. Let's think of it this way. Let's take our phones, our mobile phones, as an example, and look at the apps on our phones. If we were to apply this LRU policy to it, what would happen is that it would scan our phones and get to know the apps we use more often and the apps we don't use more often. And this, in effect, will remove all the apps that we seldom used on our phones. And that is an implementation of the least recently used in a real life scenario. How does this least recently used cache memory operate? It operates by tracking data with the help of counters, stacks, and most recently by scanning through a list of data and getting to know the frequently used from the unfrequently used ones. And with this, it would help to remove all the ones that we use in oldest time. Let's look at an advantage of the LRU. Some advantages are: one, it helps to improve the performance of the CPU because it removes data or items which are not used frequently. It would help to create space, and when that is done, this would help to improve the general performance of the CPU, which will in effect improve the overall performance of our system. Secondly, it is logical and easy to understand. Once the sorting is done and it removes the frequented items from the ones that we seldom use, this would help to make our data list or our cache logical and systematic and more easy to understand. Now let's move to the disadvantage of the URL. It is not suitable for very large caches. That is one disadvantage. And secondly, it needs an extra tracking software to do this sorting. And this makes it very expensive to acquire. Now, some applications of the URL. One, it can be applied to the CPU cache memory itself. Two, our web browsers. Is when you look at the visited pages, we can apply it there. And last but not the least, our mobile apps, as I mentioned earlier. Then we look at the replacement scheme. What is a replacement scheme, and why then do we need a replacement scheme in itself? The replacement scheme works hand in hand with the LRU in the sense that let's assume I have a cache or yes a cache and it's full and I want to add a new data list or a new set of data. It is this replacement scheme that would help to decipher the data that is not used frequently from the ones which are used frequently. And by so doing, it will remove all the ones that are not used frequently, therefore creating more room for the new data list or items to be added. So you see, with this, the LRU and the replacements can work hand in hand to improve the general performance of the computer. This brings us to the end of our presentation. This is Group 11 and we presented on the following topics. Thank you.
Amaji Robert Ajeti, presenting on cache directory. A cache directory is also part of a cache system. What is a directory? A directory is a location on the computer where files and other directories called subdirectories are stored. It helps organize structured data. What is a cache directory? A cache directory is a location on the file system, usually a folder where application or operating system are stored temporarily. Does not need to persist forever. Some of the data stored in the cache memory are web cache, package or build cache, app or specific cache, or OS level cache. Functions of a directory. Directory serves as a speed up data access because it stores your most frequent accessed data, example images, files, and then computation. So the system doesn't need to regenerate or reload every time. Examples are web browsers, cache, website assets like CSS, JavaScript, and then images. Reduces redundant operations. This helps avoid repeating expensive operations like network request, file resizing, and then data queries. Offline assets. In some in some cases, it helps you access your data offline, and then it serves as a temporary storage. The data doesn't need to persist, so it can be deleted anytime and then safe.
Hello guys, I am Michael Edwin. We are Group 11 and we are presenting on the cache memory. And today I'll be taking you guys through what cache miss rate is. So cache miss rate occurs when data cannot be found in the cache memory, or it is the measurement that shows how often the CPU fails to find data in the cache memory and has to go through a slower process, which is the memory or the RAM, to get that data for us. So when this happens, then there is a cache miss rate. The formula for cache miss rate is number of cache misses divided by total memory access. So this is the formula for the cache miss rate, and we have an example to make us understand how this formula actually works. So the example reads: if your system accesses memory 1,000 times and 50 times the data is not in the cache, then the cache miss rate in this instance is 50 divided by 1,000, which is equal to 0.05 or 5%. So this formula actually makes us understand how this example makes us understand how the formula actually works. And there are types of cache miss rates. We have the compulsory
miss, we have the capacity miss, and we have the conflict miss. What does the composition miss mean? Composition miss is also called cold start. This happens when data is actually accessed for the first time. So when the data is actually accessed for the first time, usually composition misses happens because the cache is initially empty. There is nothing saved on the cache. It's initially empty. So what is actually going to access? What are we accessing from the memory if the cache memory is actually empty? Unless there is a pre-loaded something in the cache. For that one, there can actually be something that it can actually access from the memory. But when there is nothing in the memory, in the cache memory, then the composure misses happens. That's the first type of cache misread, and the second type is the capacity misread. This happens when there is not enough space to hold all the data in the data it's actually run or manipulating. So when the size of the cache misread is very small and there is not enough space to hold all the data in it, capacity misread actually happens. So when data is too small, or when the size of the cache memory is actually too small for all the data is actually manipulating, then capacity misread happens. And sorry there is conflict misread. This happens when blocks of data is actually fighting for one particular spot in the cache memory. So when blocks of data actually fight for a particular spot in the cache memory, conflict misses happens. But the thing is that when this actually happens, there are actually extra spaces in the memory that's actually free, that these blocks of data can actually access, but they all prefer to access one particular space or size in the cache memory. So when that happens, there is a conflict misread. And there are importance of the cache misread. The importance of cache misread is it tells if your computer is actually slow or fast, and it also saves power and money. This definition is actually explained that if the cache misread is actually high, then your computer is actually slow because it keeps running far to the RAM to actually go and access the data and bring it to you. So this definition actually, what actually means is that when the cache memory, when it's actually go when you're actually going to search for the data in the cache memory and you can't find it there, it just has to travel another distance from that cache memory to the RAM, which is the RAM, to actually go get that data for you. So that space, that actually, that time that it took, it can actually make your computer slow. Or when the cache memory rate is actually low, it means your computer is actually fast, it runs fast, which means that when you're actually getting that data from the cache memory, when you go with, there is data in the cache memory which can actually be accessed, so your computer actually processes fast. And the other importance is that it saves money, power and money. This is if your computer finds what it needs in the cache memory, then less electricity is actually used. So when what the computers actually want to access from the cache memory, if it accesses it in a very short period of time, which means that there is no power actually being used to actually generate more electricity to access the cache memory, which makes us save data because save power. And when we are saving power, it means we are actually saving money in this instance. So this is the two importance of cache memory. We actually explained cache types of cache memory and what cache misread is. Thank you guys, and thank you guys for this.